Hi Universe, I'm AG and welcome to the second unit called Relations. Before discuss about relations, let's introduce another set operation, the cross product between two sets. As any operation, this will give as a result another set, called the cross product of A on B, and it will contain as much as the product of their elements. Notice that despite the same size, the cross product of B on A is a completely different result. Now, the resulting set of the operation can be seen as the set of ordered pairs whose relation is given by the cross product of A on B, or the cross product of B on A, where the first and second element in each pair are related by the set operation. Also, a relation of a set with itself can exist, by example, in the 2- or 3-dimensional plane. It is said that our universe is inside an R to the 3 space relation because any location can be expressed in function of the width, height, and depth. So, a relation of A on B is any subset of the cross product. The domain is the set of the first elements in every ordered pair, and the range is the set with the second element. So it is said that for the cross product of A on B, 1 is related to C, but in this case we haven't found an ordered pair with C as a domain and 1 as range. Also, for the cross product of B on A, C is related to 1 and 1 is not related to C. For the given relation composed of these pairs set, identify as true or false the following propositions. For this relation, the domain is composed by the set of every first order pair element, and the range is the set of second elements. First, let's evaluate the affirmative ones. The only valid relations are 1 to y, 1 to z, and 3 to y. Now let's see the negative ones. This is false because 1 is related to z, and these are correctly negated. The inverse relation is denoted like this. To find the inverse relation of A on B, just swap every ordered pair element from the given relation. Now, there will be 3 ways to graphically represent a relation. The first one is by a math expression. In this 2-dimensional example, the relation set is every ordered pair who satisfy the circumference equation. It could be infinity number of pairs. I'm just writing the points where the circle intersects the axis. The second method to represent a relation is by a directed graph that is composed of vertices and directed edges. For this A on A relation, this will be the representative graph. Also, we can represent a relation by its finite sets and the truth table matrix, where the 1 and 0 represents true and false respectively. A composite relation. Let's see. Given R as the relation of A on B and S as the relation of B on C, then can exist a relation denoted by RS between A and C, linking the common element like this. Given the relation R of A on B and the relation S of B on C, list the composite relation elements and show them in a finite set diagram. We are looking for a composite set. 2 is related to C, and 3 is related to X, and 3 is related to C. Now, we express this in a readable way, and finally, only having all the pieces, the diagram. In some cases, you'll find a composite relation expressed by a matrices. Again, somewhere people like this way, a graph or finite set still being the most efficient way to do it. Finally, thank you very much for watching our video and stay tuned for the new content.